We have a question from a client regarding the Adams Rite 4300 series dead latch that has monitoring on it. And the question is on this is an electric latch. Does the 4590 paddle latch experience its operation governed by the 4300? The client's wondering if that electrified latch, when it's in the fail secure condition, there's no power, the door is locked, does the 4590 actually work or not? Well, let's dive into these parts. What we'll do is we'll take a closer look at actually the part numbers the client's asked for, and then we'll look at the parts and see what the situation is. Let's do that now. This part of the video is going to end up being a dive into what the client has asked and determining what they're asking. This person's first language isn't English, and I only mention that because we have to be more focused, I think is a good way to put it, to help someone who may not possess the benefit of being a first language speaker. So I try harder is what I'm trying to say. Okay, so here's the question. I watched your YouTube channel and would like to find out more on this particular product in order to offer it to my client. The below attachment is the list of products which was specified. Here's the hardware set. A 4300, a 3M, a 201, a 628. We'll dive into that. A 4590, 02, 00, 628, and then an adapter plate. Yeah, I don't know where this adapter plate is going to be used. It's very likely that they're removing an existing MS-1850 and want to put access control on the opening, and that adapter plate apparently is possibly needed. I've not really encountered it. Let's just take this over here. I understand that the electric dead latch is like the mechanical dead latch, but powered and controlled by electricity. Yeah, I agree with that. My assumption is that when the signal is sent to the electric dead latch, it will allow the paddle to be able to operate the latch. But without an electric signal, the paddle would not operate anything. Am I correct? I mean, obviously the knee-jerk reaction is no, that's incorrect. That push paddle is always going to be available, but we're gonna demonstrate whether it is or not. Let's tackle that part first. What is the adapter? The adapter plate is the second component of this. Okay. So let's look at the manufacturer's catalog. All right, let's dive into the Adams Rite catalog. In my website, if you go get home, type in just Adams, you'll find products. Click on any of them. Click on the logo here, and then you'll get a link to the product catalog, which is currently here. So when this loads, let's dissect our part number. 4300 3M 201 628. Control F. 4300. Steel Hawk 4300 Electrified Dead Latch. Let's find it. All right, here's the page. Okay, our Steel Hawk 4300. I've sold these. I haven't sold a ton of them, but I've never had any trouble with it. The Steel Hawk 4300 Electrified Dead Latch is a non-handed, narrow backset electrified dead latch designed for easy integration with access control. The function I will leave. No, the standard unit. Let's just cliff note this. Standard fail secure 4300 electrified dead latch works on 12, 16, or 24 VDC power and is rated for continuous duty. That's really important. So you can hold that latch back all day long. You'll have electric dogging. Units are equipped with a quick connect plug-in connector, interchangeable without style modifications for MS deadlocks or Adams Rite 4500 and 4900 series dead latches. Okay, that's a tip-off. Turnkey. Turnkey, apply voltage or operate handle. Well, that's the answer to the client's question. You can operate the handle or paddle to release the spring-loaded latch bolt. So You are able to operate the latch by either turning the key on the outside, applying voltage, or operating the handle or paddle to release the spring-loaded latch bolt. So obviously a review or a dive into the cut sheet would have answered question 1. But here we are. Easily interfaces with other access control system elements, available in fail-secure configuration only. Right. Lock accepts any standard 1 5/32 diameter mortise cylinder with an MS cam. 3 back sets are available. I'm just scanning this to see if there's anything else important. Current draw, that's important. You want to make sure that you select a power supply that's appropriate, or a transformer if you're using a rectifier, which you could. Dimensions, basically what ends up being the template. Now, the important part is 4300. So this client has a 4303 M201. A 4303, so we know that they're dealing with 1 1/8. It's an M, so it's monitored. That's interesting. There is monitoring on this. That would explain why there are extra wires on my unit. Yeah, we knew that, but we're going to take a look at it. It's a 201, so it's a mortised. The strike, the strike that's in the box, is a mortise strike for a flat standard jam, and then it's 628. Okay, so easy peasy. Let's switch back to the camera view and let's dive into powering this and then seeing what the operation of that 4590 is like. So we're going to work on number 1. And number 2 we'll dive into next. So let's switch to a camera view. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's take a look at our power supply. Basically, this is just a whole mess of jumper wire that I've got here. Not jumper wire. This is just connected down to my terminal. And this is a discontinued Locknetics 510 that I use for these projects. So let me get the power connected to this. Power supply is calling out. We're not plugged in. On the lid, here, hot, and then neutral, and then ground. Okay, hot is black, neutral is white. You do that enough and you just end up memorizing it, I suppose. Hot is neutral and hot's the first one. So I'm going to put in, hot is neutral. White is neutral. I'm going to put that in because it's a little harder to get to with a wire in the way. I use this cable on multiple power supplies. Probably have countless bad extension cords laying around. Okay, so we're connected there. Okay, so I'm going to plug this in. We should see a light down here. This is a 2 amp power supply. Obviously you want to be quite mindful of touching things inside of here. I obviously have this wired in, the black and yeah, okay, so I've got a wire nut on the green lead, so that would be a good thing to do. When you've got those 2 wires, you wouldn't want to ground them on anything inside of here. So I'm getting a green light. I know that I'm set on 24 volts. Well, I know I am because I've looked. 24 volts. That's slid over to the 24 volt side. So voltmeter is next, or multimeter. First thing I'm going to do when I wire something is I'm going to make sure that I've got voltage coming out. I'm expecting 24 volts, so that's DC voltage. I'm going to go straight to my terminals. Doesn't matter which they are in terms of polarity, in the sense that you'll either get a positive integer, which I'm there, 27.3, or a negative integer. The negative integer just tells you that you are dealing with reverse polarity, so you just have to swap them around to get the right. So now, by means of this, that negative or positive, you know which is the negative leg, the black in this case. So terminal 5, so the green wire is what I'm driving at. That's negative. The red wire. So the green wire, this is negative. The red wire is positive. So we're getting voltage. We'll turn that off. We'll move it out of the way. Oops. So obviously the question was: does the fail secure? So the question is, first of all, we have 7 wires coming out of here. Don't be scared about 7 wires. It means nothing. These 4 wires have a plug on them. When you order the 4300, and I know this because I've read the instructions, but I also know this because I sell this. You've got 24 volt and you've got 12 or 16 volt. We're doing 24 volt, so I'm going to just use this one. What that means is the way that the wires are connected inside of the plug and how they mate to the plug coming off of the 4500, all that thinking has been done for us. I'm going to connect that because I know that we're doing 24 volt. At this point, I should be able to just touch these wires down to the output voltage, and I should get action coming out of it. What they don't do is tell you which is positive and which is negative on this. Interesting. All right, let's disconnect it, and let's just actually wire it. I'm going to wait for that light to completely go out. When all else fails, check it. Yeah, there's a micro amount of voltage still coming through there. I don't know a lot about electricity, but I know that capacitors are probably involved here. You can watch that voltage value slowly decrease. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. The bottom line is, once you disconnect a power supply, it's been a minute. We still have a micro amount of voltage coming through there. So, obviously it's safe at this point. But give it a minute when you unplug it. Okay, so I'm going to wire this now. Power is off. Grab one of my wires. And a wire nut. Another wire nut down here. Red. Red is the positive. Well, that makes sense. We can at least remember it because red is positive, which it is in low voltage, generally. It's powered. It's wired, I should say. Let's plug it back in. Okay, so I heard a click, which would be normal. I understand the client's question a lot better now. We're powered. We've got voltage. Now I'm going to remove power. Aha. You notice that it was... Wait a minute. Interesting. Very interesting. Okay, maybe it has something to do with the fact that the lock is laying down. Did we have it upside down? No, I don't think so. Sure works differently when it's upside down. This trigger here is strange. I feel it move. It becomes immovable. Oh. Well, you can do it. You can move it. Having the faceplate on there can sometimes give a different operation, but I don't think that's the case here. We're dealing with bevel tab. Okay, that's nothing. That's literally not important. Huh. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. I'm getting voltage to the lock. Yeah, I definitely am. There's no doubt that there's voltage present there. We are plugged in, so let's be mindful of that. Okay, that's unlocked. This is fail secure. The only way it's made. So when it's powered, you can move that. That to me makes sense. Now when we unplug it, this should something's not right with this. It's as if the solenoid is upside down. I power it, I turn it over. It's unlocked. If I remove the power, it's still unlocked. Okay. Alright, I'm going to take a minute to study this. Okay, it did require a second look at the installation instructions, then it dawned on me, when it comes out of the, and there's power here, it dawned on me, when it comes out of the box, this is not how it's in a normal locked condition. It's not, because the deadlocking tabs are thrown. This is going to work every time, which is how it would. What you're seeing here is as if the door was in the open position. If this was in the closed position, you'll note on the strike, it's got a hole here and here, which makes it reversible. But you'll note that in all instances, the dead latch is going to come right into the center area here. When the door is in the closed position, the dead latch will be in. At that point, I can rotate this. So when the dead latch goes in, dead latch is in. Dead latch is in. We're powered. Yes, we're powered. Dead latch is in. We should be able to go back and forth. Now, when we remove the power, dead latch is in. Now it does not slide back. Let's go through that again. When there's no power and the door is closed, the dead latch will be in. You cannot push that back. Okay? When there's power applied and the door is closed in the closed position, because this is fail secure, this will go back. Right now it's unlocked until you remove the power. Once you remove the power, which I'm going to hold the dead latch in, we've got a green light on the LED, which you can see now. Okay, I'm going to remove the power. We know that's going to take a little bit of time to draw all the voltage off, but let's assume that it's a minute. At this point, door is closed, there's no power. This should be locked, and indeed it is. Okay, now, mystery solved. Now, where I found that was operation instruction. Press aux latch to secure main latch, your auxiliary or your dead latch. Turn key, apply voltage, or operate paddle handle to unlock main latch. As door opens, main latch pivots and collapses. Yeah, so what happens is you don't, with this lock, it's not like an MS 1850 where the key action is actually drawing the latch back. This latch is never drawn back. The only thing that the solenoid is controlling whether or not it can be pushed back as a result of pulling or pushing the door open. The physical action of forcing the door from 0 degree open is what will force this to collapse. That's what's happening with this. Now, the key operation, and we don't have any voltage. Let me put voltage on it. I'm going to thread a cylinder into it. That's an unusual 3/4 inch length cylinder. It's just the first one I found that had an Adams Rite cam on it. You'll use these for really thin doors and mortise locks. Alright, let's get that threaded in to the point where it will work. I'm going to tighten down the set screw just because I don't want it moving on me. The cylinder, that is. Okay, we're basically locked in. There's power on. In a normal condition, that's depressed. Not sad, just in. At this point, we got power on, so this will not... Oh yeah, this is good. There is power, because we're closed. It's fail secure, which means when there's power, it's unlocked. Now, if I removed power, which I just did, if I remove power, door's closed, there's no power, that's in, this will now be locked. Watch the cam as I turn the key on this flapper. It pushes that down, as you can see right there, right at the tip of this finger. That action is what now will allow you, we're locked, for that latch to collapse. When it's not, it can't collapse. Now, by virtue of all of that, the cam plug, which is here, is here. That cam plug is going to sit inside of here. Okay. You won't be able to see it when it's installed, but turning the, and I have the wrong cam on here for this, the way that I put this together. But when this is seated inside of here, the spindle from the 4590, when you push that, it's going to rotate that. That rotation is going to force the cam on the back of the cam plug to move. It's going to do the very same thing, have the same net effect as turning that key on that flapper. That's there, okay? It'll do the very same thing. You push the paddle, and you'll be able to exit because you push the paddle, it forces the flapper down. You'll then be able to push the door because now that will collapse. So, you can open the door by either key outside. When you're in the closed position, the dead latch is pushed in. Flapper is up. Key will push the flapper down. You can pull or push the door open. Door's closed. This is locked. 4590 push paddle. The cam on the back of the cam plug will push the flapper down. That's how you get out. That's how you egress. Third way, with voltage, I plug it in. Door's closed, which means the dead latch is pushed in. I can always pull or push the door open. Just push-pull operation because flapper is down and I'm powered. Okay, great. That lines all that up, and let's move to the second part of this question. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. It dawned on me that I've forgotten to talk about the switch, the monitoring that's here, and the manufacturer's paperwork tells us monitoring. Options. Optional Form C. Latch status monitoring available. Form C. Form C if you don't know what that means, it won't really help you much to know what it is. But Form C, if you looked it up, that means single pole double throw. What that means is you'll have 3 wires. You'll have a common, a normally open, and a normally closed. You'll only ever use, well, you could use all 3, but you would typically only use one of the two of the 3. Always the common, and either the normally open or the normally closed. You could use them both, but the purpose of the latch monitoring is to know the condition of the latch. And the condition of the latch, and I believe it's monitoring the dead latch. The purpose for monitoring that is you'll know whether it's out or it's in. Out means the door is open. In means the door is closed. Maybe. So that's what that's intended for. The problem with that type of monitoring is I could open the door and then I could push the dead latch in. That's going to send that, it'll send a signal. It'll report that the circuit is open, meaning the door is closed, but it's really not. I've pulled the door open, I've put my thumb over the dead latch, and now I've got something coming in and out, but I'm showing through the monitoring switch that, well, the door is closed, but it actually is not. So when it comes to monitoring, there's a lot that you need to do in terms of understanding whether the door's in the closed position. So how that would be very easy to defeat that in terms of that basic monitoring, but what you could do is you've got latch monitoring. That's good. You could also have a strike that has keeper monitoring so that you know if the latch is inside of there or not. Well, that's easy to defeat as well. I could stick my finger over the dead latch and my finger in the strike, and that will satisfy both conditions. Third, you can have a door position switch somewhere in a concealed area where the door has to be closed in order for that to work. Could you bypass that? Yeah, technically you could. That would take more knowledge and probably half of a door position switch to be able to defeat that. And at that point, if the security is such, there's probably going to be someone at the door 24 hours a day. So let's switch the camera around and let's take a look at the Form C, or the single pole double throw switch that's there, and we'll discover why it's there and how it works a little bit more. Let's do that now. Okay, for this operation, we're going to need our multimeter again. I called it a voltmeter earlier. It's a multimeter is what it actually is. And a multimeter, and we have voltage. A multimeter does multiple things. It obviously checks voltage. It will check amperage. It'll check resistance, measured in ohms. But also what it's used for, if you're not checking voltage, you're probably checking continuity. And if you're not checking voltage or continuity, you're probably checking resistance. Resistance is how you can check whether or not a motor is good or bad. If you know the ohm range for a motor, you can tell if there are shorts across those windings. But continuity is really, really important. All continuity is telling you is whether or not you have an open or a closed circuit. So we're powered right now. So right now this is unlocked. Right, okay, so these were the other 3 wires. 4 of them are for power, which, yeah, 2 is for power, but these are the 3 wires for the switch. Now, it gets hot. I kind of discovered that there's a little trigger right here. There's a piece of metal that exposes itself when that latch goes in, and when it comes out, it's thrown. I bet that's the single pole double throw leg of this mechanical switch. So I'm going to leave that right there. So right now the door is open. I don't know, it's important to know the door is right now open. I don't know of red, black, and white, confusing colors if you're thinking, you know, low voltage, line voltage. You know, I may have used other colors, but it just doesn't matter. We're going to check for continuity. So in this condition, we've got a common. We know that we have a common because it's a Form C. We've got a normally open and a normally closed. I'm going to put my probe, my lead, to one of the wires, and then to another wire. Okay. You should be able to hear that beeping. That means one of these is the common, And one of these is the leg that's going to be normally closed. Or no, normally open. Let's grab the other one. If I get no continuity here, that would tell me that the black is common. Yeah. I'm getting no continuity. Now, well, actually, it's a tip. If I were to push the latch in and I get continuity with these two wires, which I do, I know that the black is common because I can satisfy it in either condition. When I push the latch in, the continuity will drop off. See? So I just happened to guess right. It doesn't really matter. You would repeat that process until you've got one wire that you never swap out and another wire that gives you continuity in one position and not in the other. Yep. Now, if I were to simply get rid of the black wire and use white and red, thinking one of these is common and the other is normally something, I'll get nothing in either condition. See? That proves that the black is the common. So what would you use this for? Well, you hear that little buzzer. I could wire this to a klaxon if I wanted. I could wire it to an annunciator. I could wire it to a sign. I could wire it to probably a cellular phone dialer, whatever. You're limited by imagination. The important part is, do you want the circuit to be closed when the door is open? Oops. Okay. When the door is open or the door is closed? So, no. Do you want to send a signal when the door is closed? Or when the door is open? Signal when you've got red. No signal when the door is closed. When you pick up the white. No signal when the door is open. Signal when it's closed. So by means of this Form C switch or a single pole double throw, you can monitor back to something of what's happening depending on the position of the aux latch, of the dead latch. That's what the monitoring does. A klaxon is a word that I don't use very often, but it's the horn that would be on a ship. So you could definitely not limit yourself to just the regular items that you might report. An LED light, a sign, an annunciator. You could do anything. You could do almost anything. With relays and with other power supplies, you could really make the position of this latch do many other things. Okay, let's go to step 2, and I think step 2 is figuring out what in the world is this adapter plate for. Obviously, it's here for a reason. I don't know what that reason is, but let's discover that now. Okay, let's dive into what this adapter plate is. In our hardware set, we have a a 91-0912-130 adapter plate for converting MS-1850 or /4089. I think that's a lever installation to dead latch and lever handle or paddle. Okay. So some paperwork and then a couple of fasteners or machine screws in here. A pan head machine screw and then a flathead machine screw. And then this here plate. Let's take a couple of basic dimensional properties. I've never seen this that I recall. I don't even know if I'm holding it the right side up. About 5 3/4 by about an inch and a quarter, inch and 5/16. Thickness looks like it's about. Oh, I'm a bit rusty with this. .105. Remember Karnak? 0.105. Oh, not awful. 0.121. So I was a 64th of an inch off. 0.121 thick. What is 0.121? The thickness of a Adams Rite adapter plate. If you remember Karnak, you're not exactly young anymore like me. So what is this? let's dive into the paperwork that I have. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, Adams Rite catalog for the 91-0912. Let's see if it's in the catalog. I would think that it's not. Yeah, nothing there. Let's take a look at the price list. Okay, so there's a 91-0912. Okay, that's in the price list, which is typical. Adapter for converting MS1850. So this is, yeah, this is all good. Installation to deadlatch or lever handle and paddle. So let's refresh our memories what a 4089 is. Let's refresh my memory. Exit indicator is what it is. Okay, so if you have a MS1850 and an exit indicator, apparently, okay, you've got a deadbolt and an exit indicator. Okay, and you want to convert that to a deadlatch and a lever handle or a paddle. You apparently need this adapter plate. Okay, so let's do this. Let's go to the Adams Rite website. Right. Split screen here. I want to pull up literature, installation instructions and templates. Let's get the Steelhawk pulled up. Okay. Let's study the MS1850. So, lock body, holes for cylinders and or thumb turns, obviously an exit indicator. So that's key, that there's an exit indicator. The exit indicator is something we should probably look at as well. 4089, because that's probably the tricky part. Installation instructions and template. Yeah. Here we go. Okay, so you've got an MS1850. Holes here if needed, as needed. Edge prep, exit indicator down below. That is going to work in the that exit indicator. It's got a pin on the back of it. Yeah. And right in here, when that bolt throws, that pin here is going to reside inside of here. That there's something moving on the inside of there. I don't have one. I don't have a lock body here. Otherwise, I would just show you. Yeah, right in here, like where a foot bolt would go into. Okay, awesome. It's probably the same pin as well. Now, this adapter plate, let's take this, let's throw that over here, since this is really the prep we're dealing with. Yeah, okay. So the 4300 just requires the same type of prep, if not, well, either identical or extremely similar. Not identical. but extremely close, but not identical. Okay. 4,300 over here. The dimensions are really close. So close that it might even work. Okay, so you've got an exit indicator, and that does indeed make sense. Because you're going to have to install a 4590. Let's take this a step further. This client's installing a 4590. Nope. Yeah, okay. Yeah. So obviously the adapter is going to help us fill out the holes needed for the exit indicator. However, what's really missing here is an explanation of why it's needed. And there is a document with the adapter plate, which I'm going to take that out of the packaging and see if I can get the document number off of that, which I can. Actually, let's just see if we can find it in the Adams Rite site first. Okay, so let's do -09-0912. Let's see if we're feeling lucky. No results found. Okay. The document number is Adams Rite 80-0180-234. No, I don't even have it in my site. No. Okay, I don't see it coming up anywhere. Yeah. All right, let's switch back to the screen view and let's look at exactly what this is going to be used for. I can't find an electronic version of it. Okay, so paper. Here we go. You know what? It'll be really easy if I just cut to the chase here. That's what we're doing. You're covering up holes. You're allowing the adaptation of the hardware to the door, whether you're using a 4590 push paddle or a lever handle. Over here, yeah, just showing how you're going to get that material installed. That's page 2. Page 1 is here. I'm going to scan this and I will get it uploaded to the site. But at the end of the day, that's what you're dealing with, and that's what it's going to look like. So yeah, it's a very unusual circumstance where you would use or need that conversion plate, but not really, in the sense that the adding of access control to doors that don't currently have it is a everyday thing nowadays, and has been for years, in fact. If you walk around, I've walked around Manhattan, one of the oldest overall general areas of real estate in the United States in terms of a modern, New York, from Central Park all the way to Battery Park, has existed since the war for independence. The point of that is it's a really old area, and you're going to have 19th century architecture everywhere. Some of the oldest buildings in New York have access control. 20th century inventions, really. Don't quote me on that. I think there was some electrified hardware that was under Tesla's umbrella, but it's since the 70s when electromagnetic locks kind of were first there, up until 50 years later. It's been a really slow incline, but it's everywhere, even in one of the oldest areas of the United States in terms of population. So the fact that someone's adding access control to an opening, yeah, it's an everyday thing. If there's anything we can help with on Adams Rite stuff or any sort of clarification that we can provide, please feel free to reach out to us. Thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.